So this is our flip video on chemical reactions. So we'll get our presentation started so we can take notes. So chemical reactions, if we look at it in terms of how we looked at chemical bonding was the dating of elements and how they sort of hook up together to become stable. We need to look at chemical reactions as the relationship now has a breakup. All right, things didn't go well, something happened, and now the elements or compounds have split apart. Okay, so we need to talk about what a chemical reaction is. Right? It occurs when elements and or compounds interact and then get rearranged. So they're not in the same relationship that they were before. They're bonded or connected to new things, or they're on their own, they're single and not connected to anything. Chemical reaction, it's written sort of like a math equation, except there is no equal sign, and we'll talk about why there is no equal sign. All right, but there's two parts to this reaction equation. One is the reactants, and that's on the left-hand side of the arrow, and then you see the arrow there, and then we get the products. The reactants are what go into the chemical reaction, okay? So it's kind of like a recipe. It's all the ingredients that go in. Then you have the arrow, and then the products are what happen as a result of the chemical reaction, all right? What do we end up with at the end? And that arrow, you actually have seen this before when we did our breakout. That arrow represents a yield sign. So we don't talk about equal, we talk about what gets yielded or what gets created as a result of the chemical reaction. So reactants go in and they yield or create products, what we get out of the chemical reaction based on what goes in. All right, so how do we know a chemical reaction has taken place? There are a couple that we're going to use our sense of observation, vision, all right, to see most of these, okay? But there is a change in temperature, all right? There could be a change in state that is unexpected, all right? Of course, my phone is ringing in the middle of a flip lesson. Or there are other visible changes that we can go ahead and see. Okay, remember, a chemical change means we have altered the substance and we now have a new substance. Okay, so a chemical change means we no longer are talking about a piece of paper, we've burned it, we've done something to it to cause a change in the substance itself. Okay, so let's talk about a change in temperature. All right, does the reaction give off heat? So if we were to feel the beaker or whatever, if heat is given off, this is called exothermic. Heat is exiting the reaction. Does the reaction absorb heat? So if heat is not given off in exothermic, like an exit, then the reaction is absorbing that heat. That is called endothermic. All right, heat stays within the reaction. All right, a change of state. There is a formation of a gas. It might fizz or bubble. All right, if the container has a lid on it, the gas will actually get trapped so you can see that gas in the change of state. This is called a closed system. Okay, sometimes that gas escapes. For example, if we burn a piece of wood, we are changing the state of the wood, but a lot of the gas is escaping, which is part of the piece of wood to begin with. Okay, but if we could put a lid on that fire and trap that gas, we wouldn't lose anything out of that reaction. If there is no lid, the gas will then escape. All right, that is called an open system. Sometimes a formation of a solid is created. You guys know this vocabulary word. So if we mix two or more liquids together and they form a solid, that is called a precipitate. All right, that too is signs of a chemical reaction. Then there are certain visible changes that we can take a look at to determine if a chemical reaction has taken place. Is there an unexpected color change? Was light created due to an explosion or a fire? All right, those sort of things. So it's really important to make sure visible changes, we're looking with our eyes. If we can't explain the color change, then it's going to be a chemical change. If we see fire or an explosion, we light a match, anything with light being created will be chemical change. All right, can a reaction be altered? Can there be anything done to a reaction to change or speed up what happens? And the answer is yes. We can change the rate of a reaction, all right, or we can change the speed at which that reaction takes place. All right, we could stir the reactants. So we could stir what goes in. If we do that, we're agitating those molecules to the point where they're going to bump into each other a little more frequently and rapidly, which ultimately will be causing a chemical reaction. Heat the reactants. If we add heat to the reactants, this will cause those to be even more agitated than they would be stirring them, which is going to force things to break apart because of that agitation of adding heat. Or we can add something called a catalyst. All right, a catalyst is basically designed to react with something to cause the reaction to occur more quickly. All right, this happens all the time in our body. We have enzymes that act as catalysts to speed up the rate at which food gets digested and put back into our systems. Okay, so catalyst is a new vocabulary word that we're going to talk about and even do a lab with after Thanksgiving. Okay, all of three of those methods add energy to a system, which is going to result most typically in a change of state, creating a gas and or a liquid. So there are 4 types of chemical reactions. Okay, not every reaction is the same. It depends on the elements and compounds involved. It depends on if there was any energy added, what the result of that reaction is going to be. Okay, so the first one is called synthesis. Then we have decomposition, single replacement, and double replacement. And we're going to look at each of these 4 types of reactions a little bit further. Okay, a synthesis reaction, when 2 or more elements or compounds combine to make a more complex substance. The word synthesis you've hopefully heard before in like photosynthesis. All right, in photosynthesis you are creating food using light for plants because the word synthesis means to create. Okay, so in a synthesis equation we are actually creating a new complex substance. So if we look at it in terms of our equation, we have our reactants. We have A plus B is going to yield the new complex compound AB. All right, and so if we look at it in terms of letters, this is what that chemical equation would look like. If some of you are visual and need color, let's look at it in terms of colored circles. Okay, so the red circle represents element A. We are going to add that to the blue circle, which is element B. That is going to yield a compound of 1A bonded to 1B. All right, we have created a new complex molecule or a new complex substance. Okay, the opposite of synthesis is decomposition. Okay, when something decomposes, it actually breaks down. Okay, so compounds break down into similar or simpler substances in a decomposition reaction. So here's what that looks like with the letters A and B. All right, we have a compound AB yields or gets broken down into element A plus element B. If we go back to our colored circles, we would have AB, the compound, being broken down into or yielding element A plus element B. Okay, notice it is the opposite of a synthesis reaction. Okay, so composition or decomposition and synthesis are opposites of each other. Synthesis, we are creating a new substance. All right, in decomposition, we are breaking that compound substance down into simpler substances. Okay, single replacement is exactly what its name says. We are going to replace a single element with another. All right, this occurs when one element replaces another one in a compound. So if we go back to our letters, we're now going to add a different letter to this. Okay, so if we have compound AB plus element C in the chemical reaction, that will yield AC plus B. In the replacement, the letter C replaced the letter B and vice versa. Okay, so if you take a look, AB was the compound plus element C. That will yield compound AC plus element B. If we look at it in terms of our colored circles, here is compound AB. We are going to add that to element C. That is going to yield compound AC plus element B. All right, so notice we single replaced. We replaced this blue circle with a green circle, and then this green circle was replaced by the blue circle. They just flip-flop spots. Now a double replacement, and I apologize, I could not get that yellow circle off of there, but it will make sense here in a minute. In double replacement, we are replacing 2 different elements or atoms to 2 different compounds. Okay, so here's what this would look like. We have compound AB plus compound CD. That is going to yield in this chemical reaction compound AC plus compound BD. So what has happened here? The C took the place of the B, all right, and then the D took the place of this one as well. The B and C created, broke up and created a new compound here. I'm sorry, the CD broke up and created a new compound here. So compound AB broke up and became compound AC. Compound CD broke up and became compound BD. So if we do that in terms of colored circles, here is compound AB plus compound CD All right, so we have compound CD here that yields compound AC plus compound BD. All right, and we're going to take a look at these chemical reactions. You're going to learn how to, one, read the elements and compounds that go into it, and then determine, is it synthesis, decomposition, single replacement, or double replacement.